Good afternoon, everybody, and thank you for having this presentation. In fact, if you look at my title carefully, it's not the same than in the proceedings. I have added two words, the red words, and that makes a very different meaning of the titles. Because, in fact, Nicolas Pinault asked me, do you want to talk about your SensoBase story? Because I'm afraid I may need some talks for the big data session. And I said, OK, why not? And I cannot refuse anything to Nicolas anyway. So I made this title. But in fact, I don't have big data. I have a database. That's it. So the first sentence of the title is pretty obvious. Many small data can make a big database. So I'm just going to tell you the story of the SensoBase. I will tell you very briefly how we analyze these database of descriptive, quantitative, sensory data. And we had three aims for building this database, and I will give you some data, true data, about the result we found thanks to this database. And then I will conclude. So how the story started. I mean, during the first 15 years of my career, I was writing SAS macros for analyzing sensory data. And I was almost the only one with my colleague in Dijon able to use them. And then I said, OK, I should make something with these SAS macros. And then the idea came of exchanging runs of these tools against data. And so the idea, you just let your data in your SensoBase, and I will return you very fancy outputs from sophisticated statistical analysis for your data. So the first team was Sylvie Cordel, Delphine Brajon, and Nicolas Pinault for his PhD, because the famous Pinault is famous for the TDS, you know, but we did the TDS before the SensoBase. And because I didn't have any money for making a PhD on TDS, so we did the PhD on the SensoBase. Then, after I had two other PhD students working thanks to this SensoBase, Nadra Mamas and Caroline Pelletier. She presented two posters this morning and offered a very nice scaling tutorial yesterday. And so I'm going to try to summarize everything they found thanks to this database. It's 9 years of research summarized in 15 minutes. OK, so we launched a website. And on this website, people came and upload an Excel file in a given format. And in exchange, they receive outputs from canonical variate analysis, cap table, flash table, for those of you who know a little bit about my favorite tools. So now we have stopped this website because we have our own software, TimeSense, and now if you want to continue contributing to the SensoBase, you can do it in TimeSense. As you can see, we have close to 2,000 datasets at the moment in TimeSense, and 1,340 are profiling datasets. I'm going to talk only about these datasets. OK, so how we analyze that? Suppose I want to address the very interesting question, is a male or female better panelist? OK? Then how am I going to merge this number of data sets? So Nicolas, in his thesis, proposed a first method, which is that one. In that method, you see the experimental unit is the subject. OK, so we have a variable data sets and a variable subject, and a characteristic that I'm interested in, and a statistic of performance that can be repeatability, discrimination, or whatever. And the model is characteristic plus dataset plus characteristic cross dataset. And dataset is seen as a random factor. And we developed also a specific weight system for these things, because the number of male and female may not be balanced in all the datasets. So in a very unbalanced dataset, I will download the weight of this dataset in the analysis. So that's one way of doing it. A most recent way that Caroline preferred is that one, in which the line is the datasets. Okay, and so we have less experimental units, less degrees of freedom, but it's better balance, of course, because now I have one line for the male, one line for the female in each data set. And the model is pretty obvious. It's a two-way ANOVA model, right? Okay, so let's go on to the first objective we had when we built this database, just documenting the practice of sensory analysis. And so these data are based on 316 clean data sets coming from 66 data providers, 38 in France, 28 in 16 other countries. And the median data set, not the average, the median, that's important, includes 5 products, 11 panelists, and 22 attributes. These data sets, 30% of these data sets has only 1 replicates, half of these data sets are 2 replicates, and 10% are 3 replicates, and a few of them have more. So the interesting things that we can extract from this base is, for instance, documentation of the percentage of scale being used, whether they are continuous scales, discrete scales, and so on. Also here you have the percentage of the attributes according to the sensory modalities. Okay, so that was the documentation. Now a very important question that a lot of panel leaders asked, they said, okay, I did replicate and I have a standard deviation over replicate of, say, 1.5 on a 0 to 10 scale. Am I good enough? We just don't know, because what is the truth? What is the value that can be achieved? So we have tabulated this value observed in 800 data sets here, and you have this standard deviation presented according to the type of products in line and the sensory modalities. So for instance, for the taste, on dairy products, it went down to 0.61, the standard deviation, all the scales being transformed between 0 and 10, of course. Okay, and that's the number of figures behind this mean of standard deviation. And I mean, the experimental unit is a triple, panelist by product by attributes, of course. Okay, so we can see in green the best, in red the worst, and suppose I am doing QDA on, I don't know, meats, for instance, and for the taste, I've got, meat is not a good example because I don't have enough value here to be sure. So let's stay here. So if I'm doing dairy products, maybe if my standard deviation over replicates is much larger than that one, then I can at least say my panel is not as good as the other panel having done the same type of sensory modalities and type of food. Okay, so I believe this table could be very useful to panel leader. We didn't publish it so far because I was not very happy with the way we computed the data cleaning, but now we are ready to publish it, and I will propose that to FQP sooner or later. I hope soon. So the second objective was optimizing sensory panel. So these are 3 very important questions, I believe, for sensory panel leader. Which individual characteristics relate to performances? And individual characteristic can be the level of training, how much session you spend to train new panelists, or would the elderly or the senior panelist not good? Question like that. The second question, how many subjects should a panel include? Okay, we have seen that the average number, the median number was 11, but can we go below or not? And the last one, do we really need replicates? Okay, so we've done some computation on these 3 questions. So I just give you an example about the age effect. So we have split the age of the trained panelists in 3 categories: below 40 years old, between 40 and 60, and above 60. Okay, and you have here the performances that we have screened: discrimination, disagreement, scaling, and repeatability. And that's the first way of doing the analysis, and this is the second way. This one is the Nicolas one, and this is the Caroline's one, I can say so. And what we found about the age effect is, if you look at that, the estimates of the scaling effect, that is the extent to which people spread their score on the sensory scale, is lower for the older people. They use narrow portion of the scales, and that was found by the two methods. And interestingly, these people seems to be more repeatable, because that might be due to the fact that they use a smaller part of the scale also. And but there is no effect on discrimination. The senior has not worst. I mean, they are a little bit, but that did not reach significance. Okay. And about disagreement, then the two ways of analyzing these data did not give the same answer. And we need to really understand that better in the close future. Okay, how many subjects should a panel include? So Nadra Mamas in her thesis took take a data set of size n and pick randomly 100 data set of size k, being lower than n, of course. Then she started with k equal 9 minus 1, then 9 minus 2, and so on. And then reanalyze the sub-data sets and compare to the results based on the full data sets according to 3 criteria: correlation coefficient between the two product mean score, RV coefficient between the two product configuration, and product F value per attributes, and MANOVA F statistics, that is discrimination, okay? And so I won't go into the details, but in our manuscripts, then you can find these tables in which you have here the number of subjects in the panel according to different sensory modalities, and there were about 12, as you can see, and that's the recommendation based on this computation. And you can see that this number go down to 961 for the flavor, and even a quite strong reduction for the appearance attributes from 12 to 6. So that's its substantial reduction of panelist number. Okay, do we need replicates in a sensory profiling study? So that's a joint work of Nadra and Caroline, and I believe now, Al, we are almost ready to send you the paper. And we have softened our former conclusion. So, so we took data sets composed of 2 replicates, 377 data sets. Why not 1,300? Because we need to sample. We need to take not too many data sets from the same data provider, and at the end of the day, we had only this number of data sets. So, so if we analyze, based on the first replicate only, we have 60% of significant attributes for the product effect instead of 67%. So it's a loss of 7%. And the average correlation coefficient between the two product mean score is very high, 0.94, okay? The median being even higher, okay? The multivariate discrimination, the ratio between 2 reps and 1 rep was 2, but the median was only 1.2. So the multivariate discrimination was not strongly better. The average RV coefficient between the two product structure in the first 2 dimensions was 0.9. And then when we compare product 2 by 2 multivariately by the Oetling T2 test, the percentage of similar diagnoses, either equal or different, was 90%. When we interpreted the biplots, and if we compute the angles, the maximum angles between the same attributes in the two analyses, after Procustus rotation, of course, this average maximum angle was 40%, which is not too big. Huh? It's something like that. You're still pointing towards more or less the same quadrants of your map. 5% of product pair were no longer discriminated. So now we would say the second replicate does not bring much more information. And of course, we also took dataset with 3 replicates, and really the third one, you should, I believe, forget it. In average. So it means that some of you should not. Yes. The third objective was to compare sensometrics techniques. Usually when a statistician has a new technique, he takes the high-risk data sets from Fisher or whatever, 1, 2 data sets, and I really believe it's not enough. It's not enough. We should base conclusion on much more data sets. So 2 examples. We investigated what the mixed assessor model recently published with Per Brokoff brings in addition compared to the usual mixed model. So to make it brief, that's the usual judge plus products plus interaction model. The MAM, the mixed assessor model, decomposed the interaction into one part due to the scaling. That's the slope of the individual product means towards the means of the panels. So when you spread your score very high, you have a beta, a slope higher than 1. And when you underspread, it's lower than 1. And that's the covariate, the x-axis, which is the product mean score over the panel. And then the remaining interaction is called a pure disagreement because it is cleaned off the scaling effect. And we don't care about this. I mean, if you're ready to adjust for the level, which is the judge effect, the level of the score, why not agreeing to adjust for the scaling effect, which is the spread, the range of the score? Okay, so what does it change out of 236 data sets? So first conclusion, the scaling heterogeneity is definitely there in your data because 45% of the attributes exhibited a significant scaling effect. We can test whether the slopes are different among the judges. So it's there, 1 time out of 2. 23% of the individual scaling coefficients were tested different than 1. At the individual level, 1 time out of 4, the judge either over or under spread his score. And if I take 1 panelist in 1 data set, I have 92% of them which for at least 1 attribute got scaling different than the average. Okay? So scaling heterogeneity is in our data. So product by panelist interaction is a pessimistic view of disagreements because 29% of the significant product by panelist interaction were found in the MAM, what I call the pure disagreement, whereas it was 48%. So in fact, 40% of the usual significant interaction were just due to scaling. Okay? That's a good news for you. The mixed assessor model increased the power, that is the ability to detect product differences, but I would say moderately, to be honest, because 64% of the attributes were significant, whereas it was 58 with the usual mixed model. So it's a gain of 6%. But 19% of the non-significant attributes in ANOVA become significant in MAM, whereas the other way around could happen also because of the difference of degrees of freedom, but it was only 4% of them. So all in all, it's 10% of the attributes that change their diagnostics towards the existence or not of a product effect, considering the MAM. My last examples, that's about CVA, canonical variate analysis. a technique I like, and I will finish in less than 3 minutes. We compare PCA to CVA, and we found very good RV coefficient, very small maximum angles, and only 5% of disagreement in product pair comparisons, and also sometimes in the advantage of the PCA. So we still publish our paper, and we were a bit disappointed. But then we corrected for both the level and the scaling effect. So these columns, it's when you correct only for the level effect, and then when you compare 2 by 2, then it increases drastically the number of pairs being discriminated, and the same thing is slightly improved here when you consider the scaling. Okay, so just a plot, that just a data set. This is the CVA with the confidence ellipses without taking into account neither the level or the scaling. Here, we take into account the level. That is, basically, we remove the judge effect. And here, in addition, we remove the scaling. We have 2 different ways to remove the scaling. Those who came yesterday to the scaling tutorial know exactly what is this difference. For the other one, I would refer you to Peltier's paper. There is some very important question to address when we do that kind of exercise is my base really representative of the field under interest? How to be sure that a data set does not contain fictitious data or training data? We should make impossible to answer several times the same data sets, okay? So that seems very simple, but because of this question, we had to remove hundreds of data sets before running the computations. And the meta-analysis process is something like that, but where you state precisely the objective, you define the criteria to be computed, you select your data set suitable for these criteria, you validate the data selection, representative, no outlier, then only now you run the computation. Then you get mistakes, errors, and possibly you return to perfect that. Okay, conclusion. I believe this SensoBase is a unique database in our field. I haven't seen other. And I think benchmarking panel performances is highly expected by panel leader because it's subjective data. Despite training, it's really subjective. So you can't expect standard deviation to go towards 0. It's impossible. Our recommendation about number of reps and panelists could maybe save a lot of money to companies. And that brings us a rational framework under which we could, I didn't have time to show that. Nadra Mamas did power computation using the real data to estimate the samples, the size effect, the heterogeneity of the population, to help you in running power computations. And it's a reliable investigation of the real impact of sensometrics techniques, okay? What does it change? Sometimes it does not change much, but it's better to know. Okay, so my message to the major company like Nestlé collecting a huge amount of descriptive data is pull all of them and gain knowledge by analyzing them together. I think you have to do that. Maybe you already do that, but we haven't seen much paper about that. Maybe you don't want to publish that. So talking about paper, these are the paper of my bright PhD students. And no, just a small ads for 2 coming conference. I think you should consider coming to the Sensometrics conference in Brighton in July, and Brighton by the Sea. Okay, so that's a great conference where you have everybody interested in the statistics and sensory data. And it's going to be very well organized because I know these people pretty well. And there is another conference that I strongly recommend. It's Eurosens 2016 in Dijon, and that's in September, 11 to 14, and Dijon is wonderful. I can tell you that we will have good wine, good food, and good science. Thank you very much.
Thank you, Pascal. You make it clear, especially for the last one. And almost within the timelines. So if you have a quick question, we can have a quick question before moving to the round table.
Pascal, who are better panelists, men or women? You didn't tell us, actually.
Who are the best?
The best panelists.
No, there is no. Sorry. There is no gender effect, and what we have seen, Caroline, correct me if I'm wrong, that maybe the male scales, that was more or less? Caroline, where are you?
I don't remember.
No, I think the male scales more, but none of the two genders were more discriminative, because that's the key question. For a long time, we believe female was, but because sensory analysis is led by females, you know, and we have a lot of females in the panels. And then someone one day told me, but the males you have are not representative of the males. And that's a good point, because we have a few of them, and it's very unbalanced. And maybe the one we have, I mean, they are much more interested in food, cooking, and all these things. So the representativity is maybe not perfect.
Thank you.